So hello again. Today I would like to go through Azure Storage account through Azure Storage Service. I guess last week you went through Application Insights with my colleague. Today I would like to continue with the original lab where we will add a few lines of code to connect to Azure Storage, and we will use Azure Storage for storing files or any binaries. In the first lab we will add a few files to the storage, to so-called blob storage, and in the second lab we will familiarize ourselves with the queue storage, with Azure Queues, which you can use as first in, first out storage for messaging, for the very basic messaging, whenever you want to pass any signal or message or whatever in between your components of your system. For example, in between the front-end application and any worker or job behind that, you can use queues. So one question, all of you have an active Azure subscription with the solution we were working on the days before. So can we continue on that? Did you have any troubles as you were completing the lab or with your subscription or whatever?
Like the second part of integrating it with the smart grid for the emails.
Mm-hmm.
I had like a bit of trouble. I don't remember which trouble I had, but the rest was fine. Just I might need to redeploy it because they cost too much.
Sure. But you were able to create the SendGrid account and great. So the description or the instructions for the lab, you can find them as usual on my GitHub account. You can use the short version bit.ly and the code of this course, or the long one, github.com, Hackener, my nickname, and cloud development. Today I want you to go through lab 4 and 5. And I will go with you, and you can follow me, or you can do on your own. Wherever you get stuck in any troubles or whatever, feel free to ask me or stop me and just shout, and I will help you. So we will start by creating the storage account. There are many ways how to create it. You can create it directly from Visual Studio, but usually you create your storage account from Azure Portal. So I will start in Azure Portal, which is portal azure.com. And in my subscription I can pick one of the resource groups I've got there. I don't know if you created some additional ones, but there should be at least one with the resources we created in the previous lab. So in my case it's the cloud development resource group, and here I will add a new resource, and it should be one of the first you see there. It's called storage account, blob file, table, queues and other, like the green tile. Now there are several options you have to pick. The first one is the name. There is one restriction, or at least one. The name has to be in lower cases, so you are not able to use Pascal casing or Camel casing for the name. And there is a limit, I guess it's 25 characters in length, 24. So I will pick Cloud Dev 4, it's lab number 4, Cloud Dev 4. The deployment model, it's nowadays it's always the resource manager. The old classic one is no longer suitable, so you don't have to think about that. The account kind, there are several types of accounts. The very original one, it's the general purpose V1, which was upgraded to storage account V2. The only difference there is the pricing, where the storage account, where the V2 allows you to pick whether your data are so-called hot or cold, where there is a difference in the like the SLA provided there and the performance. You can use the cold, so-called cold model for backups and archiving, and usually you use hot for any like live data you use in your application. And the last one is the blob storage. It's like a dedicated version of the storage account, which allows you only to use only the blob API and the blob part of the functionality. So for our purpose we will use the V2, which allows you not only creating blobs, but there are also queues, tables and stuff like that. There are two performance tiers. The difference is in price. Basically you can think of them like the standard one, it's the like a regular hard drive, and the premium one, the performance there is similar to SSD drives or something like that. So we will stick with the standard one. The replication there, every single storage account does have some type of replication. The data there are always stored in several replicas to protect you from the data loss, and the price is different for the different types of replication. The cheapest one is the locally redundant storage, which means that both of your replicas are stored within a single data center, Azure data center. So it's protected against hardware failure of the drive which stores your data, but not, for example, against the earthquake or whatever thunderstorm, which might destroy the completely the whole data center. And the most expensive one is the geo-redundant storage, which replicates your data in between two data centers, two different zones. And in the middle, the read access geo-redundant storage means that you can use only one of the replicas for writing and the other can be used only for reading data, which is kind of compromised there. For basic application, we will go with the local redundant storage. The pricing there, basically with the geo-redundant storage, the price is double the price of the basic local redundant storage, and you have to pay the data transfer in addition to that. So, as we said, it was last time or in the first lesson, whenever your data leave any Azure data center, you pay for the data transfer there. It's not expensive. It's something like I don't know, like $3 per 100 gigabytes or something like that, but you have to take it into account. Then there's the access tier, which I described earlier. It's the option for a V2 storage account version, and allows you to set whether your data are like only the archive one, which is cheaper, or if you have so-called hot data and you need immediate access to them. And the last important option there is whether you want to secure the access to that storage account to require HTTPS. Basically, all the access to your data or to the storage account API goes through REST API, HTTP access, and this switch says that HTTPS will be required for any API call. So you usually want to have this enabled. The only exception might be some legacy application which is not able to communicate via HTTP secure transfer channel. Sorry?
You get charged more for using
No, it does not affect price. And this option only tells that the HTTP will be completely disabled. If you leave it disabled here, it means that both options will be available. So this is like required. Disable the HTTP and require only HTTPS for the communication. Resource group, we will use our resource group and location. You usually want to have your storage account in the same location where your application sits, at least to prevent the costs for data transfers. And the very last option allows you to configure your storage account to be accessible through VPN, but it's not our case, so we will leave this disabled. As you create the storage account, it usually takes a minute. The most important thing you will need to access the storage account is the account key. It's basically something like a password. It allows your applications to access the account and to upload data, download data, create containers, or do whatever is needed. There are several types of keys. Now the storage account is created, so I can go to resource or refresh the resource group. In the detail of the storage account, there is a access keys section where there are two keys, key 1 and key 2. These are the so-called master keys, which are used to protect your account and to sign any API calls to that account. You can use them directly, or you can create additional keys, so-called shared access signatures, SAS, which can have limited access rights. For example, only to download data, or only to list the files there, or read the data from the queue. So if you need limited access for some of your components, or you want to give access to someone else, for example, to be able to download your files, or as upload only, to be able to upload files, you can create specific SAS keys, which are basically derived keys signed by one of the master keys, key 1 or key 2. And these additional keys, they are self-contained or self-describing, so they are not stored on server side. There is the signature of the master key, so whenever you want to invalidate them, you have to reset the master key. And whenever you reset the master key, key 1 or key 2, that means that you always invalidate all the derived keys. Whenever I create a new derived key here, the SAS key, I have to pick if it will be signed by key 1 or key 2. These are the two master keys, these two. In the master key section, access key section, there are the keys itself and the connection string for each of them. So this will be the connection string we will use for our application. You will have to copy and paste this connection string to our application. So now we can go to our application, and the very first and simple step we will want our application to do is to upload a file to the storage account. Every file has to be placed in a container. Container is kind of a logical unit, like a folder, which allows you navigation to the files, or which contains your files. And you usually create the container from the Azure portal. You can create the container from your API, directly from your application, but in practice it's usual to create a container from Azure portal. You can think of the container of being something like a letter of the drive, like the C drive or D drive or whatever. So I can go to the overview of the storage account, and there are 4 sections for the 4 different areas covered by the storage account. Now we are working with blobs, the files. The second file section there It's only a specific version of the blob storage which is used for example, for virtual machines or for remote access to allow you to map the storage as a usual network drive. But it's not the case of if you are developing a new application, you don't use this like a mapped drive. You use the direct API to access blobs. So we'll go to blobs and create a new container there. Pick whatever name you want. I will go for test. And you have to set the access level of the container. Basically, all the containers are private, so you have to have the key to access the container. But you can create the container to be accessible through HTTP, and then you set the anonymous read access for the blobs, for the container. And for example, you can use such container for image files of your websites. If you want to have your websites deployed in several instances, for example, you want your websites to be able to share the images or share any data which can be downloaded directly anonymously. Then you go for the anonymous read access, and the URLs you get for those files are directly usable from within internet to download the files. But in our case, we will go for a private container. And it's done, it's created. So now we can go to our application and to test the upload, we can create a simple web form which allows you to pick any file from the browser and to upload that file to that storage container. So I will use the code snippets from my instructions. These are the controls, web controls needed to upload the file, or to pick the file which might be uploaded. And in the code behind, I have to add the code to execute the upload itself. It's the handler which handles the click for the button there, and basically if you look at the code, there is the cloud storage account class which allows you, which is like a basic class which allows you to parse the connection string and to create so-called storage account instance, which allows you to create several clients. One of them is the cloud blob client, another, as we will see in the second section, is Q client, and there are other clients. Then you have to create a reference to that container. It's in the first 3 or 4 lines. There is actually no communication with the storage account, so it's all on like the client side, just creating the references and like only handling all the stuff on application side, and the communication itself, it's only the last line which executes the request against the server, against the storage account and uploads the file. To be able to use this API, you have to reference or add a NuGet package to your application. It's the Windows Azure Storage NuGet package, and you can add that, for example, using the Manage NuGet Packages for solution, the NuGet Package Manager here. If I will look for storage, it's the first one, Windows Azure Storage, and I will install that into both of the projects in my solution. This is just struggling with my local setup of the NuGet, but this basically adds references to the libraries, to the SDK needed to access the storage account. Yes?
When we need to add the storage connection string to the web config, which key needs to be used here?
You can use any of those two keys.
And
so
where exactly should we put the value?
I will show you in a few seconds.
Okay.
Sorry. So now as I installed the NuGet package, I can add the missing usings. And the connection string itself, you can, for the test, you can hard code it here, but in real application you want the connection string to be extracted in your settings, and for this demo I picked the application settings, and the key of the application settings in this case is the storage account connection string. So I will have to go to webconfig, and in the webconfig file I have to add, it will be a new section here, app settings, and in the app settings section I will add key storage account connection string, and the value, it's the value from the portal. So I will pick the connection string for the first key and put it here. In real application, you usually don't put your connection strings in the webconfig file. As we saw in the second lesson, I guess it was in the second lesson, you usually put these settings to application settings section in the Azure portal, or in the for your app service. So if I go to the app service, which is in this case maybe the old one, it's the cloud development app. It's the app service used to host my application, and in this application settings section, this is where you usually put your connection strings. It can be either the application settings section or the connection string section. For example, this is the storage account connection string I used when I was preparing the labs. So, but if you want to test your application locally, you have to have the connection string available in your Visual Studio. There are some more options or alternatives which you can use to access your connection string within from Visual Studio, but it's out of scope of this course to go through them. You can use so-called Azure Key Vault, which is like a security service in Azure which allows you to store any secrets for your application, like the keys, connection strings, the settings of your remote services or whatever, and then you can use a special API to access those secrets stored in that key vault. It's kind of like a password manager in Azure, which is being used for the applications, not for the users. But for the very simple demo, we can use the connection string in webconfig file in the app settings section, and if I run the application now with the code I added, it should have a simple user interface for picking a file, any local file, and with the go button it goes through the several lines of the code and allows you to upload that file to the storage account. So we can try that. For example, this PDF file, go. To check whether the file is uploaded successfully, you can use the Azure portal, and in Azure portal you can go to your storage account. You can navigate to your storage account. And if you open the blobs section and navigate to the container we just created, the name of the container was also within the code. And if you open the container, the file or the files you are uploading should be there. There is one very useful tool you can use to manage the storage accounts. It's called Azure Storage Explorer. I will show you just very quickly. If you want to install that, you can Google for that. So it's called Azure Storage Explorer. It's a Microsoft product, cloud storage management, this one. And download the Storage Explorer, and the application itself, it's this one. It allows you to browse through all your storage accounts and the contents of them, and do some basic settings of the storage accounts and stuff like that. So if I go to my MSDN subscription, the Cloud Dev 4 storage account I just created, there are blob containers, test, and there is the PDF file I just uploaded. So were you successful in uploading the file to your storage account? Right. Now we can go through two additional simple scenarios. We can list the files from the storage account and we can download the content of the file there. So to list the content of any container, you can use the API available in the Azure Storage SDK. I will take the code snippet from my instructions to have some UI to display the result. I will use repeater in the markup. It's just one of many ways how to display a list of something. And to get the data for the repeater, I will, for every single request, I will for every single request in the pre-render phase of the page lifecycle, I will create the container reference as the same way as we did it for the upload, and this time we will call the list blobs API to get the list of all blobs there. The list blobs API is quite simple. If you go through the overloads available there, you can basically want the blobs listed to match a basic pattern where the name of the blob can match a specific prefix. There is no like a extended querying functionality which would allow you to, for example, list blobs which with a specific extension or something like that. There is one thing to mention. In the blob name, in the name of the blob itself, you can use slash sign, and whenever you put slash sign in the name of the blob, it allows some of the tools to interpret that as a folder. So, for example, if you then take the Azure Storage Explorer, the application I showed you a few minutes ago, then you will see that as like a folder structure in your container. But in fact, it's not. It's for example, you are not allowed to create an empty folder because there is no such a entity in the storage account as folder. It's just the container, which is only the top level structure, and then under the container there are the names of the blobs. But by convention you can use slashes in those names, which allows you to organize the blobs in like similar navigational structure as folders are. And as you are allowed to use like the prefix of the blob name in the list blobs API, this allows you to list files from a specific folder, in fact. So this simple line of code downloads all the metadata for all the blobs there, the list of the blobs, and binds them to the repeater where we use them to display the list and create the links to the files. And then whenever someone clicks the file name in the user interface, the file link command method is called, and the name or the URL of the blob is passed to this method. And as you see, there is a similar API, but this time you don't need the container reference, as the container name is contained within the URL used for that blob, and you use the constructor for the cloud block blob, where you pass the URL and the blob client, which holds your connection string, and you use the download. There are many different download methods. You can download to string, download to file, which saves the blob to your local file. This time I used the download to stream to direct the response to the HTTP client. I will have to add one additional using here, and if I run this, there is just the one file I uploaded. I can add some more, for example, whatever. This one, this one. And I can download that. Well, I didn't polish the web experience here. There should be a few more instructions to tell the browser that the data you are sending to the browser are in fact the file, and to allow the user to save that as a file with a specific name. So this is just a very simple demo to show you how to use the API. So were you able to access your files and to download them? So these were the this was the blob storage account, and now I want to show you the Q storage account, which is very similar. As you will see, the API is almost the same, but the difference there is that you use it not for uploading files or binaries, but for uploading or sending messages. The Azure Storage Queues are probably the simplest mechanism you can use for messaging, sending messages in between components of your system, where one of the components will send messages to the queue. These are basically or usually small messages where the content is string, and it's usually a JSON serialization of some small object to hold the. You usually pass a workload from one component to another one. For example, if you want to use a queue to send emails, then your application, the front-end application, will send messages to this queue, and the background worker is consuming those messages from the queue and executes the email delivery itself through the SMTP server. So it's the similar scenario we were using in the first lab with the, or the second one, with the SQL table for queuing, and this time we will use the queue. The queue itself works as a first in, first out storage. So on the other side, the second API to read messages from the queue always gives you the oldest message in the queue, and to allow you some like basic transactional processing, the queue like getting the message from the queue is divided into two phases. In the first phase, you read the message from the queue, and as you read the message as one of many possible consumers which are listening to that queue, the message is immediately marked as like it's invisible for the other readers for several seconds. The default there is for 30 seconds, and within those 30 seconds you have to confirm that you process it, the message, and it can be deleted from the queue, the processing of the message is committed and the transaction is finished. If you don't confirm or don't delete the message from the queue within those 30 seconds or any other timeout defined, the message gets automatically renewed into the queue, and it can be processed by any other listener. So for example, if one of your consumers gets stuck or whatever, for whatever reason it fails, it means that the message remains in the queue and it will be processed by the other one. So as to try the simplest scenario, we have to create a queue. The queue can be created from the code, but usually the queue is created within the Azure portal the very same way as we created container for the Blob account. We will create a queue. So if we go to the storage account section, to the queues subsection, there are all the queues defined, listed. It's currently empty, and I will add a queue name test again, and now I'm able to send messages to that queue and consume messages from that queue. It's to test the queue, you are able to add message directly from the Azure portal, but it's not very usable, maybe for some diagnostics, but you can see the contents of the queue here. But now we will go to our application and add basic UI to send messages to queue. I will use the code prepared here in instructions. And the code behind that. Oh, that's the wrong one. Oh, that's the wrong one. This got some duplication copy paste error here. So it should be text box named QMessage text box. Sorry for that, text box. QMessage text box, and the button is the send to queue button. So these are the correct lines, these are the correct 2 lines. I will fix that on GitHub today afternoon. So there is a simple text box to type your message, and a button which in its handler sends the message to the queue. And the send to queue code is very simple. After the basic dance with the references, you just create an instance of the message. It's cloud QMessage, and the constructor takes the string representation of the message. You usually don't send any user entered text to that queue. It's usually kind of like a notification header message where you pass some workload to other components of your system. For example, it can be a JSON serialized object, JSON serialized email, JSON serialized instruction to do some workload, to process something, to process order, to process payment, whatever. And with the add message method, I just upload the message to the queue. What I didn't mention with the blobs, and it's the same with the queues, for all those APIs which directly communicate with the storage account, there is always an asynchronous version as well. So you can use the asynchronous pattern with the await and make that call asynchronous. So if I run this, I can use the hello word message, send the message, and as I go to the storage account and refresh the queue, it should be there. And I can send as many different messages there, and these can be duplicate messages as well. There is no like a direct support for duplicate detection. These messages are directly added to the queue. There is one important thing to mention. The messages, as they are added to the queue, they always have an expiration time. The default expiration time is 7 days, and it's in fact the maximum expiration time or time to live for the message to remain in the queue. So if your consumers get down and you didn't notice that, then after 7 days you will lose your messages, and there is no simple chance to get them back. So if you want some like more sophisticated messaging mechanism, you should use Azure Service Bus, which also has a queue functionality in it, and they are much more detailed and it's much more feature rich, where you will be able to, for example, use that letter queue there, where the service bus is. For example, you can configure that after 10 failed attempts to process the message goes to a separate queue with a reason stored there, and the expiration time can be in fact indefinite there and stuff like that. But it's much pricier than the simple queue here.
What is the other line?
Azure Service Bus is the other product.
But the underlying protocol
For the underlying protocol, the basic one is HTTP. So it uses REST calls to push the messages to the queue where there is a put or.
So like a message can be like consumed by several.
Yeah. You can use as many consumers as you wish. As the consumer connects to the queue and listens for the messages, it's the basic like the producer-consumer pattern, where you have one or several producers and one or several consumers, and the important thing there is the two-phase processing or two-phase downloading of the message from the queue, where in the first phase you get the message from the queue from one of the consumers, and the message gets invisible for the others for 30 seconds, and within those 30 seconds you have to delete the message to confirm you processed the message. But in this scenario, in these basic use, you are not able, maybe what you were asking, you are not able to have several consumers where all the consumers are interested in that message.
Yeah, like broadcasting.
Like a broadcasting one.
So
No. For a broadcasting scenario, you will have to create separate queues for every single consumer, or you have to use the Azure Service Bus or other services in Azure to do the broadcasting. Because in this scenario, in the scenario of queues, there always has to be someone who deletes the message from the queue, and none of the consumers is aware that it is the last one allowed to delete the message. There might be an option that you will keep all the messages and in the queue and let them expire.
Yeah, that's right.
Yeah. So you might implement a very simple broadcast with that.
Are you charged
For storing the messages in the queue?
They stay in the queue? The longer the time they stay in the queue?
It's being paid or charged the very same ways as far as the blobs. So in fact, it's the amount of data stored in the queue you pay for, but it's very cheap. These are like, I can use the calculator to give you the exact pricing, but it's really cheap. Stuck. So this is the storage. This is the price for the storage, for the amount of data you are storing in the queue, and it's 3.8 cents per gigabyte. And then you've got pricing per operation. An operation is upload, download, and it's quite cheap. It's for 10,000 operations. Wow, yeah, really cheap. We have like heavily used queues, and the prices are like $10 per month or something like that. So you. So to implement the retrieval of the message from the queue, now I add a label which will display the message. And the code itself, it's pretty simple. The most important is the get message method, which tries to retrieve a message from the queue, and if there is no message, then it returns null. So this specific API, there is no callback or whatever action you are able to subscribe, but you have to poll the queue and to try whether there is a new message. So you usually use this in an indefinite loop, the similar one we used for the job, and in the loop you query for those messages within with some time intervals, where you usually go for sleep between those retrievals. And the important part of this retrieval process is the delete message, the second phase. So as you get the message and process the message, you have to delete that message from the queue. If you don't delete the message, it gets returned to the queue in 30 seconds. There is an additional API. You can read the peak message without making it invisible for the others. And you can update a message in a queue, in fact. So if you want your job to run more than 30 seconds, then you have to update the message in the queue and tell the queue that you are still working on that message and you need additional 30 seconds or more. It's just the mechanism to make it transactable and make it reliable. With this very simple test, we can get message from queue. Is the first one, and you can see that the messages will disappear here. Where is our application? It's this one. Get. As I read all messages, I get null from the API. So this is it. Were you able to send your message to the queue and retrieve it back? Great. For the other options there in the storage account, if you go to the storage account and you wonder why they are tables and files, I already mentioned files, that this is a specific version of the blobs section where you are able to map those files as a network drive to your computer using the SMB protocol. And the tables, it's the very basic NoSQL database or table where you can store any table or data. You send their JSON records, but I don't want you to stuck on this, because tables are currently being replaced by a new service in Azure. It's called Azure Cosmos DB, which is a unified service for all possible NoSQL scenarios for the tabular data, and it has like a very high availability and SLA parameters in its design, and it's automatically being replicated to many locations, and it does have automatic indexing of all the tabular data there, and many other features which are not covered by the tables here. And the known intention of Microsoft is that they want to replace these tables with the Azure Cosmos DB service. So in some of the following lectures we will get back to Azure Cosmos DB, and you will see that the API there are many options. You in fact can use the SQL syntax, you can use MongoDB syntax, you can use DocumentDB syntax, you can use this old API for tables to access data in the Azure Cosmos DB. So there is no need to go through these tables. But in fact they are still heavily used, and the intention of Microsoft is to replace them transparently, so the users of these tables won't notice that the background service behind this will be Cosmos DB sometime. So do you have any questions to storage options in Azure, or how to process the data there? There are many other services to store data in Azure or to live with the messaging. As I mentioned, there is a Azure Service Bus, which allows you to create queues, which are much more powerful than these queues. And the Azure Service Bus also supports the usual producer subscriber pattern, which you can use for the broadcasting and for the publishing, for publishing any events which happen in your system and send the notification to many different listeners. Then there is it's called Event Grid and Event Hub. It's a service which you usually use with IoT devices or mobile devices where you have quite a huge amount of data being processed, and these services are specially designed to be able to accommodate those volumes of data and to distribute the data there. For orchestration and like a more sophisticated messaging, you can use Azure BizTalk as well, which is a platform as a service version, or in fact software as a service version of the Microsoft BizTalk server, which is an integration platform similar to IBM WebSphere or kind of that, which allows you to integrate many systems together and to manage the communication there. For distributing files, if you have a web application and you want to allow your users to access files from many different locations, you can put those files in blobs and allow anonymous access to that. But there is a separate CDN service in Azure as well, so you can use the content delivery network there and publish your files to CDN, and then it gets automatically distributed to all the CDN nodes and allow the files to be available for your users, and you in fact pay that as a regular storage account. But for every single location you have to pay that storage.
Cosmos DB is not open source.
I'm not sure if it's open sourced or not. It's based the source code itself, I'm not sure whether it's open source or not. These are the APIs available there: SQL, Table API, MongoDB, and the others. I guess the SDK is open source, but the Cosmos DB itself probably not. And currently, if you create a separate Cosmos DB account, it's quite pricey. It's like intention of Microsoft. It's currently only in like a preview. It's not a so-called general availability service, and it's currently focused to cover the most performant or the most important scenarios, and for services like Facebook and LinkedIn and Bing and other services of global scale. So the initial price is quite high, but they want it to replace the basic tables from the storage account, and they want to make it transparent, so the price for the very basic scenario should remain the same as the current pricing for tables, for Azure tables and storage account. The issue there currently with the Cosmos DB is that there is only one pricing model available, which is based on the reserved capacity. So you are not allowed to pay for what you consume or to share the resources with other users, but you have to have your own dedicated resources paid in Azure, which makes the service quite pricey. So this is it. Next week it will be probably my colleague Miroslav Holec who will take over this course and will continue with you with the other Azure services. He will continue with serverless computing. He should touch the Cosmos DB, probably the service bus as well. He will go through Azure Functions and other Azure services. There are 4 more lessons available, and the setup of the course should be similar to this one. So he will prepare labs for you, and within the labs he will try to tell you what are the basic concepts there and how to use those services. So that's it for me, and thank you for your attention.